Recording it. Okay, now I'll continue this. Okay, so here we send the data in again the whatever the format it needs for the chart. Okay, so these are all template we need to follow based on the how the chart.js how it needs, that way we need to form. So that's the reason I'm just following the template and sending the data in a JSON format. Okay, now we were so we were in base.html. Okay, so we will on the while loading the page, the pie chart is shown based on the based on the ready dot document. Okay. So there are two parts here. One is on load, we call it. Okay, on load by default we call this um, just give me 1 minute. So on load, we are actually filling this data for one time. Okay. So I will show you how this is filling every. I actually we saw in the consumer, right. This is getting updated for every 30 seconds. But this will be only on load. It will load. After that, it will not load by default. So you have to choose the respective sales type and hit the load. Okay. So for that, on click of this, so it will call our sorry, the filter form. Filter form is our drop down. Okay, so if this form is submitted by using the submit button, then the uh, on clicking of your submit button, so this will get called. Again, it will take the value from their drop down and call the load chart. So which in turns call the DB and get the data and run it to the chart. This is the like synchronous way of loading. Okay, where we are using Ajax call by using the JavaScript library. For asynchronous mode, so come to this. This is whatever in base.html we saw the pie chart loading coding. How the pie chart is loaded for that respective coding we saw in the these two script tags. Okay. Now we'll go back to the main.js. This is where we actually use the bar chart. How the bar chart is rendered. Again, we create we have a bar chart tag. We will get it and build this chart object. How you build it in the script tag, right? See here, the first tag, the script tag, where we'll build the chart for the pie chart. Similarly, for bar chart, we build this object, chart object, and then you have to create an object for the chart and just put some configurations. This is a very important. Okay, just give me 1 minute. I'll just save this data. training. This one. Day 4. Okay, so and then we have to actually run our we have to create a WebSocket. Okay, so we have to create a WebSocket for our channel to integrate. Okay, so that WebSocket I'm running on port number 8000. Okay, so this is where the both. So in this application, we use both the HTTP protocol based communication as well as the web based, WebSocket based communication. It's a mixture of both synchronous call as an asynchronous call. So synchronous call is handled based on the HTTP protocol. Asynchronous communications are handled using the WebSocket. So you need to run the WebSocket on the using this URL. So websocket.org 8000, and this is the kind of URL we need to use it. Okay, and then the socket.on message. So whenever the message is sent from the server, okay, so the response sent from the server, again we just have to uh, uh, render the data in a chart. Okay, so where is the routing? Okay. So if you see here, this URL pattern should match in the WebSocket you create in the mains.py, right? So it will keep on making a connection. The connection is, this connection is established once. Okay, after that it's not closed until your application is closed. Okay, that's the reason you will see the uh, this getting updated for every 5 seconds. We don't close this connection for this portion to update the data for this portion of web page. But in this portion of the web page, this is a synchronous call. But this is a asynchronous call using a WebSocket. So the WebSocket eating the URL, this one. Now this will go and call the routing method, sorry, the routing.py, which in turn call the consumer, right? This where is the, yeah, consumer.py. The consumer.py keep sending the data for every 5 seconds. That's how the flow is uh, uh, maintained, and the data is published on the dashboard for every 5 seconds. So we saw how the routing is configured, right? So when this URL hits, the ws/chart URL is hitting by the WebSocket, and then the from the WebSocket is from the client side. So whatever the code there in the JavaScript and HTML, that will be run from the browser. I think in the web architecture, all your HTML and JavaScript will run on the browser side, right? So the browser side, it will make a communication with the WebSocket. So whenever we see this URL, it will go and hit the routing.py, and run the consumer and get the data. Okay. So this WebSocket connection is established, and it will run for forever until you close your application. And for channel, right, the data is sent via channel, Django channels. For that, you just have to install the Redis channels Redis, which you saw in the reference.py, and you just have to mention that in the settings.py. Let's go to the settings.py. There is a one portion we need to mention here, the channel layer. Okay, the channel layer, you just say backend is channels Redis core.redis channel layer, and mention the host name, and by default it runs on this port. So I'm mentioning the port number. So our architecture, the dashboard architecture works same as this flow. Okay, our HTTP our synchronous call works in this manner, and asynchronous call is made in this manner. I'll just save this for reference. And this is a typical Django application, how synchronous way how it works. Yeah, and you can go through this blog. It has some basic information about how the Django channels works. There's one blog which I referred. Any other questions you have? At most, uh, I told how this dashboard works. I explained all the functionality of this dashboard.
Yeah, nothing from my side.
Okay. Thank you. Please try to set up this set up this code on your environment and try to run this. Okay.
Yes. So just one question, for curiosity, so you are looking into that particular dashboard from your from the VM that you have set up.
Yeah.
So is it so how is it possible to get it in
Yeah.
your system like?
Okay. Now what you need to do is, okay, we will do that change. Okay, fine. Good question. At least you asked. Okay. Now what I'll do is, so basically it referring because of the local host I mentioned. Even I should be able to call from here. Okay, using the 192 dot this one. Okay, so now it is not coming here. So first step is just go to this. This is the application, right? So let's start with the. You can mention here zero dot when you're running your Django application. Just say Python space manage.py run server space 0.0.0.0:8000. Okay, this is the first step you need to do. So now we should be able to access this. Okay, right? Sorry, 8000. Okay, the application is rendering, but this is not refreshing because of two reasons. One is still the WebSocket is running with the URL as localhost. You see WS in the, if you look at the code. So and Redis also pointing to this one. So we have to change this as well. Okay. So we have to change the Redis, the host name or the IP address, and also you have to change you have to include into the allowed host. Allowed host, I think that day we made changes in the file. Okay, so okay, so if the first step is you need to run the Django application with this format. Okay, that is the first point. Okay, now let's go to the. I'll stop. I'll go and open the Nano editor. Real time charts slash settings.py. Come here. Mention the allowed host. Mention your localhost since we are actually accessing from the Django. Sorry, VM I mentioned here. But if you are connecting from outside, whatever the IP address of your machine where you are running your Django application, mention the IP address. This is one point. And second point is come here, just change this
one thing like that IP address, like for the allowing the host, that IP address I should get through using like IP config
Config. Ah,
from
yes, correct.
CMD.
IP config. Correct.
Yeah,
IP
yeah. Okay,
config.
okay.
Okay, and then for Redis also you should run on that. At least Redis also should be running on this. At least otherwise we'll check. This change I will make later. Okay. Uh, uh, Control X. Control exit. Do you want to save? No. Okay. So now only this change is there. The allowed host is there. I did not change the Redis part. It's still it is pointing the 127. Let it be for now. And now you go and change the WebSocket URL. Like just go to it is there where it is there in the template HTML. Sorry, in the static folder main.js. Main.js. Okay, ls nano static main.js. Come here instead of localhost. Yeah, this is the WebSocket URL, right? Just change it here. What is the URL? It's 192. I'm recording it, right? So that will be used. Yeah, that's so 192.168.56.1. Okay, I'll just save this, exit, and now I'll just go and run again like this. Now let's just come and refresh here. Still, the timestamp is chart is not loading. What about this is loading? Because this is synchronous, I guess. Change this. This is loading. The asynchronous communication is not happening.
Okay.
And okay, there is no error. Let's go and change the Redis also and check. Stop here. Change this. Not this. Status. This one. Setting.py. I'll change the Redis URL also. The IP address. I'll try to put. We have to put. Okay, let's check. Same as our IP address. If not works, I'll put 000 but 0. Okay. First, we'll try with IP address 192.168.56.102. Save this, exit. Now let's run it again. This. Still, this is not. I think this is fine. I think this is the web. This is the old one. Okay, the bar chart is loading. Still, this is not happening. Okay, so what do you check? Do one more change. We'll come to here. Let's put here. Instead of this, this should work. This or Okay, let's try one thing. Otherwise, I'll check it and I'll check and let you know. Okay, I will put this also 000. Okay, and then try it out. Redis change I made. Okay, now let's run it here. Still, it's not coming. In the VM, inside VM, inside VM it works. Right? That means, okay, now let's go and change the WebSocket also and check. Sorry. Open the main.py, sorry, JS, and change here. Instead of this, let's put 0. Whatever. Control S, cancel. No. I'll put here 0 dot some problem with my keyboard 1 minute. Just say Control C 0.0.0. Control X. Now let's run it again. No, some it's not going. Throwing any error also. Yes, still here works fine. Okay, I'll find a way. Okay. I tried changing the IP address in both WebSocket URL and Redis, but still it's not reflecting. Okay, so it's not what I will check it in the offline. I will let you know. Okay.
Sir,
Can
I
you?
have a question actually.
Yes, yes.
One thing is that I want to ask here that suppose that if I want means we are having an application in that PyCharm, right?
Yeah.
So suppose that if I want to do the development using PyCharm, can I connect my means VM walks to that PyCharm? Is there any possibility?
VM, what is that?
That can I means local means what can I say? Virtual machine, whatever
What?
I am having.
No, in virtual
The
machine,
PyCharm.
which software you want to connect? Like which
No.
database?
Suppose that PyCharm, I am having an application where Kafka is there, right? Then
Uh,
Spark is there. Then
mm, mm,
that
mm,
this
mm,
Django application is also there, right?
mm.
And I want to run. I want to do the development. I want to run directly to the directly with the server actually, virtual machine. Okay, is there any possibility that I can connect with PyCharm to virtual machine? Like we okay. Can you just open this?
This one?
Yes. Suppose
Okay.
that if I will run from here,
Hmm.
that this should point to my virtual machine. Is there any possibility?
Mm,
Suppose that if I will run from here, it will run local, means from my desktop, right?
yeah, yeah.
So my thing is that whenever you are doing a change here, that
Hmm.
change should reflect there also, right?
Okay, so basically the code has to shift to my uh, 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 what to say, the code has to shift to the, because this is the Django application, right? Whatever change
Yeah.
development you do, like in real time also, you do the development on your laptop. How the code is deployed on server, somebody has to go and deploy it, or you need to use like like kind of Jenkins deployment tool to deploy your code from your generally they takes from GitHub. So you publish this data, you push this data, commit your changes to the Git, and create a Jenkins pipeline which will take the data from uh, what to say, Git and deploy it in a server or in your UML. That is one way.
Actually,
Other way
Jenkins.
is, other ways
Mhm.
you have to do manually, like using the WinSCP, you just copy paste your code there and run it. These are the two way I know. That's what you are asking, or you are asking if something different?
No, no, no. Actually,
Hmm.
the thing is, suppose that if I want to run that this code in locally, I
Hmm.
need to install all the things, right?
Yeah, for that, right? See, for that you actually point the code will run from here. So instead of
Hmm.
pointing your, so instead of see here, you just have to change your this. Okay, let's come to Redis later because that somehow it's not working. I will find out. Um, it should work actually. Point, you need to point to your the VMs, the respective say example, I want to connect to the MySQL, right? So you just
Hmm.
change your IP address here.
Okay. And the port should be, and that there should not be any firewall, right? That
Ah,
you need
yeah,
to
yeah.
open the
Yes,
firewall
you
also.
need to open the firewall. And similarly, you change the in the main.py, change the IP address of this.
Okay, got it. Yeah. Okay, got it. Yeah, I got it.
No problem. No problem.
Yeah, I just want to ask you that about the big data class also, that
Okay,
means
sure.
on AWS.
I'm actually starting from August 26th. Okay, so uh, August 26th, I'm starting the class. So, what is the information you need?
So what is the fee and means course structure actually?
Yeah, so basically, I am charging 10K, 10K, 10,000. So, if you
Okay.
look at it, let me show the course content.
Yeah, yeah.
D colon training. Okay. So, basically, this I will close it. 1 minute. So, these are the things I'm going to cover it. Okay, and
Mm.
the RDBMS part and the NoSQL part, it's more of integration. I don't cover like I don't cover in detail about means I'm not going to cover all the topics from the this NoSQL. Say example, different concepts in Cassandra, different concepts in MongoDB. I'm not going to cover. Similarly, in the database side, like how to integrate, right? That portion I will cover with respect to Spark. Okay,
Mm-hmm.
remaining all things I will be covering, right? So
Okay, okay.
okay, so
So
because
do you
these are
have
all
the detailed hi Pari. Do you have
hi,
the
hi.
detailed program details
Yes,
for
yes,
this?
I have it. So that's okay. So that is one part. Um, 1 minute. So this is one part, right? So we are going to cover the storage component because this is I'm going to build it. We will be developing in local and deploying it in our EMR cluster. Okay, and all the things. So and we will be using the storage component S3 for the object storage or distributed storage on cloud. And for local storage, we'll be using HDFS. Okay, that is respect to storage component. So we will be installing. I will tell you how to install MySQL, Postgres, SQL Server on our. We will be using the EC2 instance in AWS. So EC2 instance are nothing but VM in cloud, right? Uh, so we will be installing all these components. and even NoSQLs. I will try to cover some more details on HBase. Okay. And we'll see how to install all these components. That will be covered. Only thing is all the concept, because that is big area, right? And all these services will be covered. So we'll be the fully focused on PySpark, the Spark with the Python, like how we build it in our project use case. We'll be learning Hive, Scoop, and Kafka is there. Kafka is going to be, we'll learn all the concepts in Kafka. And then the automation perspective, we will use Git and Maven for the build. Um, and we'll use Jenkins deployment tool. So we'll create how to get we'll commit our code in the Git and how to deploy using the Jenkins pipeline. And we'll use for uh, uh, the Apache Airflow for the job orchestration. So how to schedule your workflow, the PySpark jobs in Airflow, all will be seen. So that's a high level. Okay, these are the components which is covered. If you go to the detailed thing, I think I shared this PDF also in the group. You can go through. Even through mail also I shared it. You can check it out. I'll just minimize a little bit. Okay, so I will be giving a basic touch point on Python programming. So mostly that will be in one class. Okay, not more than one class, because it's basically I'm just covering the basic language concepts and the pandas Python package that will be in Python programming. And when it comes to Hadoop, so we will be covering on basic concepts of SDFS and MapReduce. So this is it. High level, we'll do a few samples, and the main focus is Spark. So I'm just limitation, because MapReduce, like nowadays at least people are not using. There may be some project which is running in MapReduce, but not all, because the Spark has evolved and people started using Spark. But it's good to understand the concept, because all distributed computing came from this framework only. So we'll be learning Hive. So if you go to Hive, so we'll be learning about Hive tables, what is bucketing, what is different joins in Hive, what is partitioning in Hive, how do you, there are different concepts in Hive queries, and what are the SERDs we can use it in Hive, like different file formats, how the Hive tables can be stored and retrieved, and some what is the indexing in Hive and optimization in Hive. Similarly, we'll go to the Scoop part of it. It's an import export tool for from RDBMS to Hadoop. So whether it can import to the SDFS or it can be Hive tables. So we will be seeing that. Then what? So we'll come back to the Yarn and HBase, and then we are focused on Spark. Okay, PySpark. So we will be in the PySpark. I am covering 4 libraries. So the Spark has many libraries, right? So Spark ecosystem. Like Hadoop ecosystem had different components like Apache, as like STFS, MapReduce, Hive, Scoop, Pig. There are many Hadoop ecosystems. Similarly, Spark has these are the ecosystem components or libraries. You have a Spark Core API, and then we have Spark SQL streaming library, which our project use case was built using the streaming library, structure streaming, and MLlib and GraphX. So I will be not covering GraphX, which is basically graph-based computation. I will be giving a few examples, a few machine learning libraries. Like there is 2 major categories in at least 2 of the category in machine learning is supervised learning and unsupervised learning. we will see one algorithm from supervised learning, and which within supervised learning we have classification regression. We'll see one algorithm. So the idea was, this training was to focus on these three libraries: Core API, Spark SQL, and Fast Streaming. Little bit about MLlib, not extensive because it has deep learning, it has NLP related machine algorithms. All this I will not cover because this is a 40 hours session, so I will not be able to cover all the things. So the main focus on these three libraries with respect to Spark. Okay, that's what you will see it here. RDDs or Spark Core APIs. In Spark SQL, we have SQL based data frame based and structure streaming. Then it comes to the memory, and then we will work on the memory management and the performance tuning and the NoSQL part of it. Okay, and then finally the scheduling part, Airflow. I will also let you know how the Woozy people who have Hadoop cluster, if they are not using Apache Airflow, they might be using any proprietary scheduling tool like Control M or AutoSys. There are many scheduling tool, or they use Hadoop based scheduling tool called Apache Woozy. I will give introduction about that, and then we will focus on the Apache Kafka and AWS. In the AWS, I will focus on three services: EMR, which is Elastic MapReduce managed Hadoop on Spark cluster. Okay, all our development will happen on local and we'll be running it on our cluster. So which is EMR, and we'll use S3 and EC2 instance to build our these components. So we will be using EMR for Spark and Hadoop, and we have to use these components, right? We have to install HBase and MongoDB and MySQL, all the stuff, and even Jenkins. Airflow will come by default. You can do manual installation on EC2 instance, or actually it is bundled in EMR also, I guess. So we'll be using that. DynamoDB is, I'll just give a little overview of it. It's one of the NoSQL database in Amazon Cloud. So this is how my course content is organized.
Sir, could you please send this means
PDF
to the mail?
Yeah, it is already there in your mail, I guess. So let me, if you just check, you received this. What is that? Last mail. If you receive this mail, demo class
No,
or
I
big
do
data. So, what is your mail ID? Can you tell? I'll just forward this.
Yeah. Okay. I think I
Because
got it.
you will be, because you are part of our.
SAHU.
Sorry?
SAHU 729. Where is that? Here, okay. Let me check. Actually, I got only these. Means, can you just forward this
Yeah,
again?
no problem.
SAHU.
I'll forward. No problem. Yes.
SAHU.
Yes.
SAHU 7129. First one. Yeah.
Yeah, can you also add me? Hello.
Sure. No problem.
Yeah,
Yeah.
APU.
APU. This one,
Yeah,
right?
this one. Yeah.
Okay. Magendra, you got it? Is there?
And to check it.
Okay. You tell me your email ID.
NANDA.
This one?
Yeah, the below one. Not that one. Nandi.click you.
Okay. I'm forwarding it. So this has whatever we conducted the demo class yesterday, and it has the course content. It will not have PPT. Probably I'll just attach the PPT if you want.
No, just attach it. I think I got the yesterday's mail. I need to go through it.
Oh, no problem. I'll just attach the PPT also.